All right. Scatter plots and data student handout 2. This one is a little different because you're going to do some of the work of constructing the scatter plot. So, um, just for the essence of time, this first one kind of show you, and then I'll really walk you through one on the backside. All right, Jared's basketball team stood at various distances from the basketball goal. Count the number of baskets they're able to make in 30 seconds. Distance each person stood from the goal and the number of baskets made are shown in the table. So again, this right here, the distance becomes your, in feet becomes your x value, and then the shots made become your y value. Now, obviously, we don't have 26. Might have mislabeled a couple of these, but we'll be okay. 26 spaces. So we had to change our scale to where every box going on the X is worth 2, and then the shots can be 1 because we didn't go above 14. So when you're building that, keep that in mind. Don't just go straight throwing stuff down. Kind of put some labels in, but you can see what's going on here. And so when we look at this, and it says, what type of association do you see in the scatter plot? Well, in all honesty, if we look at this right here, if you kind of follow my cursor, that's going to be a negative association. Okay. Because as the x increases, the y decreases. Okay. Listing other observations space below. I would say we have kind of two groups of data. Okay. And one point is way out there. And maybe we'll find a better way to explain. I'm guessing we will. But you see two groups, which we'll talk about, and this guy hanging out by himself. Okay. So use scatter plot to label each statement as true or false. I'm going to switch to a little draw mode here. Okay. As the distance from the goal increases, the number of baskets made decreases. I would say true. Okay. Because that's what we see. Okay. And again, increases, decreases. They're opposite. So that automatically makes it a negative association. Okay. But also makes it true. As the distance from the goal decreases, the number of baskets increase. For the most part, true. Scribble that bad boy in. There we go. All right. As the distance from the goal decreases, the number of baskets made decreases. We do have this one right here, but for the majority of them, that's not what we see. Okay. So this would be false. Okay. As well, remember when we said negative association, that means one variable goes one way, the other variable goes the other way. Here, this is decreases and decreases, which would be a positive association. All right. So remember how I said, hey, we've got groups and we've got this little point. All right. We should be able to do this. All right. A point that does not fit in the overall group or trend of the scatter plot is known as an outlier. So this little guy right here is the outlier. Who is the outlier in the scattered plot above? This guy right there. Okay. Now, clustering occurs in a scatter plot when there are distinct or separate groups. There we go. Groups of points. Okay. We could also say group or line or trend. Okay. So we know what our outlier is. Now we can see these clusters or groups of data points. Okay. We got two clusters and an outlier. All right. There you go. All right. Let's take a look at a new one here. So populations of 10 cities listed over here. There's one after me. And the number of elementary schools it has is shown in the table. Make a scatter plot of the data. So as you can see, this is a great example of, we've got our X value, the population, bam. Number of elementary schools, second numerical set of data. Number of elementary schools right here. You can also see the scale is different. This is every 2. It's 1 box equals 2. Okay. We're going this way. Every box is 10,000. Totally different. All right. So we got to plot some points. There we go. That looks good. All right. So population 76. We'll say it's about there. And we're going to go up to, we'll just throw it down right there. More. 60 and 17. There we go. Again, remembering this is your X value. That looks more like a Y. And these are your Y values. Okay. Good little review in graphing. All right. Lufkin. 35 and 10. Let's just kind of keep going. Cheyenne. We'll place in Wyoming. 73 and 22. Right on 22. And again, this is nice where it's like, doesn't have to be absolute accuracy. Danville, 51 and 13. Dara, 78 and 26. Okay. Waterford, 25. So it's going to be halfway. And 12. 25 and 12. Prosper. I believe that's in Wyoming as well. 13 and 7. And Glens Falls. Don't know where that one is. 20. Oh, that's different. And Dalton. 85 and about 21. Okay. So now we've gone and plotted all of our data. All right. Let's switch over back to a text box. Describe any association. There we go. Between the variables. Well, the association, I would say looking at this, that would be a positive association. Okay? Because we look at it and we go, hey, as the population goes up, the number of elementary schools in those towns go up. So positive association, the number of, or actually, as the population increases, so does the number of schools. Okay, pretty straightforward. I'm going to, don't want that, I want that guy. There we go. All right. See how that centers it back out. All right. Are there any outliers? Yeah. Let's see. The outlier would be this guy who had 20,000 people, but 20. Yeah. Falls has almost double the schools for its size. Okay. If not more. Okay. Because actually, well, 20 to say 80, I would say, as four times when we really look at it. Times schools for its size. Okay. Do we have any clusters? I would say no. Okay. Because if you look, I mean, I know that gets a little close right up here up top, but yeah, I would say none. All right. Let's go down here, take a look at one more. All right. On Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data he collected to make a scatter plot. Okay, cool. Looks like homework assignments are whole numbers. Money is going to be a little trickier, but that's okay. Here we go. Size 4 should work. All right. First kid, 8, 24, and 0. Okay. 29, about over here, and 2. Okay. And 475, which is almost, and 1. So we'll just kind of put him right there. And $20 and a 0. $1.80 and 3. 11.92 and 4. $0. One assignment. That's an interesting one. That try actually get him on there. 1750 and 2. 26 and 3. All right. I feel pretty good about that. All right. So we got those in there. Now let's go back to the text box here and see what we got. Describe the association between the variables. What can we conclude from this? No association because there is no connection logically between money and homework. You cannot buy your way in and out. Okay. All right. Are there any outliers in the data? Um, no. Are there any clusters? No. Okay. When we have no association, it gets kind of weird. Okay. I mean, even if you look at the numbers, a couple zeros, a couple twos, a couple ones, a couple threes, 4. There's just really, I mean, the closest you might have here, anyway, the outliers. No. Most data is spaced out. Okay. Are there any clusters? I wonder if they kind of consider this, logically speaking, kind of down here. All right. So you might want to say, kind of, meaning low money and low homework. Okay. I mean, it seems kind of weird to say that, but, there's a little bit of a cluster down there. So, anyway, as we look at this, the big thing I want you to take away from here is defining what outliers and clusters are, as well as when you've got, so you're going to be doing a project coming up, where you've got to build your own. And so you're going to kind of how you lay out your table, those types of things. So not super heavy here, but definitely some new information and stuff to pay attention to. All right. I hope this helps.